It's been about another week. I want to show you this week's problems. It's a little bigger. So current problem is a calculus problem, but I think I've got 4 or 5 to go through. So I'll go through all these. I mean, I like to post my submissions at some point. I'm trying to do about once a week. So I figure I may as well stream it to you guys while I do it. So last week we'd gone through abstract algebra. I actually made a mistake on the last one, but I fixed it after someone posted an answer. So it reminded me. I was just not thinking. But anyway, that's why I'm kind of glad this is like a group thing. We can all sort of check each other's work. So yeah, I was going to do these 5 problems, starting with this real analysis one. Here goes. We'll just go in order, even though, I don't know, the pre-calc and the discrete problems are going to be a lot easier than this. But so our question says, for dimensions bigger than 1, if you've got a number in RK, show that there's another number that's orthogonal to it, a non-trivial number. 0 doesn't count as orthogonal. Okay, so if you're given a fixed x, can you find another number in the same space whose dot product is 0? And is it still true if k is 1? This one's actually pretty straightforward. This one's not too bad. I'm sure some of these real analysis questions will get tough later on, but so suppose you're in, suppose you've got these are the coordinates of your guy in k dimensions. There we go. I don't know what they are, but it's not as equal to 0. So at least one of these is non-zero. If only one of them is non-zero, if you had some situation where like x sub n is non-zero, but x sub I is 0 for all others, meaning there's only one non-zero entry, then it's pretty clear that you just want to avoid that entry. Let y be basically anything. Let's say let yn be 0 and yi be non-zero for some I. You don't have to do it for every I, but that's enough to miss that point, right? So an example of that would be like if x was 1, 0, you can just let y be 0, 1. But anyway, more interesting example, more generally, suppose you have a bunch of these being non-zero. You could even let all of them be non-zero. Just pick 2 that you're going to cancel out. So you're going to end up, when you dot these together, you just want that you get a bunch of zeros, so most of y will be 0. So I guess I'll just say it. I mean, to prove this, I would have to say like, okay, let xi and xj, xi and xj be non-zero. Right? So we did the case where there's only one non-zero. If there's more than one, then just pick 2. And let y be filled with zeros, except for the yi and yjth entries. We'll have somewhere in here a yi and a yj. Okay. Anyway, all you're going to do is let yi be the negative of xj, and let yj be, I want to say xi. Yeah, that's right. That's right. So just make these negate, so that when you do dot them together, the dot product now is going to be a bunch of zeros. Mostly it cancels until you hit yi xi, and you get, yep, that's right. So here's your yi value. And then here's your xj yj value. Xj yj. So that's all. Clever trick. Some sort of cancellation. You're not going to be able to do this, of course, unless there are two non-zero values. Our trick over here doesn't work anymore because it required it required a different dimension to miss it when you dot them together. So this trick doesn't work in one dimension. So the follow-up, is this true if k equals 1? No, it's not true. In one dimension, you're just not going to be able to do it, right? You just get a single number. You just get x. If x is non-zero, the only way for this to be 0 is if y is 0. All right, we can probably move on. So that's the real analysis one, believe it or not too painful today. The complex analysis one says, find the cubed roots of this number, negative 8i. Find all cubed roots, all three of them. Find the cube roots. I usually, what I do is I'll express this in polar coordinates, and then take whatever root you want. So like, if you want the nth root, you take the nth root of the radius times the nth root of this guy. Now this gives me it doesn't give you all of the roots, but it gives you, if you did this correctly and you got an angle between, say, 0 and 2 pi, when you take this root, it's still going to be between 0 and 2 pi. So you're looking at the principal value of your root, I guess the principal root. So in our case, it's kind of clear that the magnitude is 8. The angle, let's see, negative 8i. So i's up here, negative i's down here. So you're like way down there somewhere. This is our point. So the angle is, the original angle is like pi plus pi over 2, so 3 pi over 2. Right? So this number that we started with is 8e to the I 3 pi over 2. That's a number we're starting with. So I want to take the cubed root, and I'll get 1/3 of this. I'll get 8 to the 1/3, so that's just the regular cubed root of 8. But then we're also raising this to 1/3, 8 to the I. And if you multiply that by 1/3, it'll divide 3 out, right? If you multiply this argument by 1/3, you'll get just pi over 2. In other words, and that's straight up. So that's an I right there. This is I, this is 2. So one of the cubed roots. The principal root is 2i. And we can verify that, right? 2i cubed should give us 2 cubed I cubed, which is negative I. So you're getting negative 8i. So that's correct. So here's one. But there's also two more, and the way I usually get them is to, you can think of it, you can call it modulating. You're like changing the angle that this is occurring at. But anyway, there's multiple angles. This cubed root is technically a multi-valued function. In our case, it's going to be 3 different values, but here there would be n different values. You could also just use a formula like you could also just use a formula like this, like take your original angle and add 2 pi to it, then do your root action. So here k goes from 0 up to, well, not n, but I'll jot down, I'll take the cube root of just basically 1. So think of this as a fancy way of writing 1. I'll take a root of unity. So this I'll take the cube root of unity, which would be 2 pi thirds. And then if you square that, you get another multiplier, like another number you can, another angle you can sort of modulate this answer by. And then if you do this again, if you do omega cubed, you'll get this back. You'll get 6 pi over 3, which is just 1. So omega cubed is just 1. Take this answer times 1, you get itself. Anyway, I'm going to use these two. I would use these two to generate the other two roots. So we could also start with our cubed root. Here's our principal one. A to the 1/3, e to the I pi over 2. And now if we multiply by omega, you will, of course, be doing the same thing we just did over here. And another one from this side, you'd get 2 e to the I pi over 2. And if we just scale it by omega squared, that's 4 pi over 3 this time instead of 2 pi over 3. You'll get, let's see, 3 pi over 6 plus 8 pi over 6. 3 and 8 is 11, so we're getting 11 pi over 6. So that's another answer. So these are their answers in polar form. And now you're going to be taking like cosine, if you want to put this in sort of this a plus bi form, standard form, I guess. If you want to put it in sort of Cartesian coordinates instead of polar coordinates, you're doing something like this: 2 cos of the angle and 2 sine of the angle. That's one of them. So I'm going to need sine and cosine of pi over 6. And if I remember that correctly, this is the bigger triangle on the base. So you're getting root 3 over 2, comma 1 over 2. So if you're over here with it, if you're here at 7 pi over 6, then that point is negative root 3 over 2, comma negative 1 over 2. And if you're, for 11 pi over 6, we're almost back at 2 pi. We're almost at 12 pi over 6. So you're down here. Again, the reference angle is pi over 6. If you just go down, then you've got a positive root 3 over 2 for the first coordinate, but you've got a negative for the vertical coordinate there. So that's going to be how I handle the second root that I found. So yeah, now you can just double them. 2 cosine, 2 sine. So one of the roots is 2 times this, negative root 3 comma negative 1. And the other root that we found, this one, is doubling these. You're getting positive root 3 and negative 1. And so altogether, here's one of them. Another one is negative root 3 plus I times this. And the other one is root 3 plus I times this, which is minus I. So here's another one. Here's another one. Basically, the three roots are 2I is one that's very easy to check if you just cube it. We checked it already. And then this is negative I plus or minus root 3. Negative I. They both had negative I in them, you know. And we could check those. So if you had, say, negative I plus root 3 and you cube it, is it true that you get back, we started with negative 8I. So if you square it, you would get negative I squared. So the negatives cancel, you get I squared, you get that. In the middle, you'll have this twice, so you'll have 2 root 3I with a minus because there was minus I. So minus I times root 3 plus minus I times root 3, that's that. And then the last term will be this term squared, so you get plus 3. And then we still have to do one more factor, negative I plus root 3. So negative I times this stuff will give you I. Yep. Negative I times this. The negatives cancel, but now you've got I squared, so it's actually minus 2 root 3. And then negative I times this is minus 3I, sure. And then plus root 3 times these. So minus root 3I plus root 3 times this. It's basically 3. So 3 times 2 is 6. So it looks like I'm getting plus 6. Yeah, sure. Sorry, minus 6 is what I meant to say. Minus 6I, right? And then root 3 times 3, plus root 3 times 3, like that. So whatever this simplifies to be. And I minus 9I is negative 8I. Yep, it is. Negative 8 i's. The rest of it does cancel too. You've got 3, then you've got minus 2, minus 1. So 3 root 3's. Why is this here? Did I manage to screw that up somehow? It's not an I, is it? This was the second group, root 3. No, it's not an I. Sorry. It's minus root 3 times 1. Whoops. I was going to say, that doesn't make sense that that's there. Root 3 times negative 1. Root 3 times this gives you negative 6I. That was this part. Yeah, okay. So yeah, that was supposed to be root 3. Should I see if we survive one more? I don't know if we need to really check this one. You probably believe me. But this time, do we have like a double negative thing happening in the middle? So it's this same expansion, but with a plus 2 root 3I. This times that would be root 3I, but we do it twice, sort of cross terms. So you're getting negative I squared, which is I squared, which is negative 1. In the middle, though, we got sort of double negative action, so you get this. And then negative this, you get positive 3 again. Negative I, minus root 3. So negative I times all this stuff, you get I. Negative I times that, they cancel, you get I. Negative I times this, you get positive 2 root 3, I guess. Does that make sense? And then negative I times the third one, we just get like that. And then negative root 3 times this is positive root 3. negative root 3 times the middle is minus 6i, and then negative root 3 times the third is minus 3 root 3, which if I did that correctly, again works out to be I minus 9i. And I'm betting the other terms cancel. Yep, 3 root 3 minus 3 root 3. So finally we have verified that each of these is a cubed root of negative 8i. And that was the toughest one for the day. Let's go back to our little problem set. We got a precalc problem, discrete, and a calc. So yeah, precalc. It says, find the equation of a circle with center negative 2, 4, but it also contains the point 2, 1. So one of the points on the circle is 2, 1, but this center is negative 2, 4. In general, though, I guess you really need to remember the equation. It's changing in both x and y, so there's an x variable and a y variable in your answer. Usually think of a circle equation as that, with center hk. So for us, when you do x minus negative 2, that cancels and gives you plus 2. When you do y minus 4, you just get that. And what we haven't done yet is find the radius. But we know that this center, the distance between this center and one of the points on the circle, any of the points, is going to be, the distances r. So if you, basically it's a very similar formula, right? It's like the square root of the square of the distances. So distance is root, and then you can just subtract these. Just make sure you go in the same direction each time. You're consistent with which direction you're subtracting. So if you go, say, 2 minus negative 2, and square that, that's the change in x. That's this change. And then we're also going to take a vertical change. And then we're going to use Pythagorean theorem to get the distance between them. So 1 minus 4 squared. So here I'm getting 4 squared. Here I'm getting negative 3 squared. Becomes 9. So I'm getting 16 plus 9 is root 25, so it's 5. So this radius is 5. And yeah, we're just about done. Final answer should be something like that. Sometimes these are nicer, when you see them in a pre-calc class. Sometimes they just outright give you the radius, and then they don't have to give you this point. But this is probably the hardest type of circle question for these, just finding the equation of a circle questions. Sometimes they make you find the radius yourself. All right, discrete. Company offers, they have 10,000 customers. They have 2 services, internet and telephone. They tell you this many use internet, this many use telephone, this many use neither. How many use both? So this is a Venn diagram question. The total is 10,000, and they're telling us that 4,530 don't use don't use either service. Then they tell us 3770 is the size of the internet group. Some of them also use the telephone. And 3250 is the size of the telephone group. And those are the numbers. So if you had a big collection of these folks, the entire set would be 10,000. But they told you that the people that do not belong in the internet or in the telephone group out here is 4,530. So if you want to put that there, you certainly can. But if you take 10,000 minus that, it's giving you the union. This 5,040 is the number of people in the union of IUT. Now, some of those people are in the middle. I guess the real way to do this now, you have to find the intersection first so that you can remove it before I put anything else here. Like this entire circle is the size of I, and this entire circle is the size of T. If I were to add them together, you add this part twice. So that's where you get a formula like Ni plus Nt see, if you just like blindly add them, well, let me say it this way. It will give you the union, but it'll add the intersection twice. So I'm just going to say it the way I've sort of memorized it, but when you add Ni to Nt, you counted this twice, so you want to subtract it one time. If you subtract it once, the intersection, then you'll get the correct answer for the total in the union. So we have all these numbers except for this intersection. Now we can start. Actually, I think that was the whole question. How many use both? So sometimes, you would be asked to fill in this entire Venn diagram, which is basically what we're doing, but we want to find this intersection. Anyway, again, if you add all of I and all of T, you'll get something like that. You won't know this, but the whole concept was that you added it twice by accident. Well, you added it twice when you did this. We do know that we're supposed to get 5,470. So you can add this and subtract that, and you'll have your answer. But anyway, let's add these. 250 and 770 is like 1,020. And then you got 6,000. So this all together is 7,020, I want to say. So you could add this term and subtract that term. Anyway, that's what we're after. This actual number is what? Let's see. It's 1,000 something, right? If I add like 530, you'll be almost there. It must be 550. And we could maybe verify that if you like. If you subtract that from this number, you'll have the people that are in the internet group, but they're not using a telephone. So at this point, I'm just kind of rambling, but you could verify internet and not telephone is 3,770 minus this intersection that we found. And telephone without internet is, of course, this minus that intersection. Oops. There you go, like that. But I'm just kind of thinking out loud. You could use this to check your work because the sum of all these should, of course, be 10,000. But I'm going to assume that's correct and move on, I think. So the last one we want to talk about today is a calculus problem. Average velocity. So a ball's thrown in the air with this velocity. Its height is given, so its position vertically. Its height is given by this formula in feet, t seconds later. What's the average velocity of this beginning at time t and using like a step size or an interval length of whatever is given here? So we're gonna do this 4 different times, and then there's also like a follow-up question. So basically find the average velocity if you're given position and you're given an interval. We start at 2 and we have half a second, 1/10 of a second, 20th of a second, 100th of a second, and then use these numbers if you can to estimate what you think the velocity would be at time 2. So this is average velocity. I guess you'd sort of need to know a formula, but if your position is, well, we actually have our position as 40t minus 16t squared. So it's like 40 divided by 16 sounds like it should be the time at which it hits the ground. We get a little shape like this, 40 over 16 is not quite 2. It's a little bigger than 2, right? So that's good. So I don't know where 2 is. I doubt it's at the peak. It's not at the peak, but say 2 is like right here. If we zoom in a bit on that, you have something like this, where here's 2, and we're stopping somewhere, like say 2.5. So we're finding the average velocity from here to there. I drew it like a straight line, but it's not straight, right? It's curved. But nevertheless, you're basically doing something like the slope equation, You want to get the change in the function's values divided by whatever that length was. So for us, for part A, the change in time is 0.5, and your interval is 2 to 2.5. So if you're thinking in terms of like A and B and what's the formula supposed to be, this is A, this is B, you're basically getting a slope every time. Like here's the change in Y, and here's the change in X. So this is your average velocity formula, or really average change, average rate of change of the function. It's the slope of a line that touches there. Well, actually, it's called a secant line because it touches at 2 points on the curve. It's not actually a tangent line. Tangent usually touches in 1 point if you zoom in, but this guy touches in 2 points, this line that we're talking about. So anyway, the average velocity here would be like f of 2.5 minus f of 2, and you just divide by the difference is 0.5. And then I'd need a calculator, but we're plugging in 40 times 2.5 minus 16 times 2.5 squared minus what you'd get f of 2. We're going to use this again and again, so it might be easier to just compute f of 2. So we're getting 80 minus 16 times 4. 16, I guess. So this part is 16, the f of 2 part. And you divide all that by 0.5, which is a lot like multiplying by 2. So yeah, still a mess. Now there's the numerical part. You'd probably grab a calculator and crunch those numbers. Which I guess I will do. Let me see something real quick. If I take 2.5 and square it, what do I get? That makes some sense, I guess. Sure it does. All right, so multiply that by 16. That's the part we're subtracting. So I'm getting 40 times 2.5. So 100 minus 100, that's cute. Huh. Oh, is 2.5 really the time that it hits the ground? It doesn't, I mean, okay, sure. Apparently. That's okay. That's okay. I would be a little annoyed if this was negative because the model stops making sense. So I would have probably changed the problem if that was the case. But yeah, that's not a big deal. 2.5 squared, yep, is indeed 6.25. Not much else to say, so that's okay. We're getting, so for the first part, for part A, we're getting 0 minus 16, we said, over 0.5 is negative 32 is our first answer. For part 2, you just repeat this but with 0.1. So you're going from 2 to 2.1. In other words, your formula becomes f of 2.1 minus f of 2. This time you divide by the step size 0.1. So again, f of 2 is 16. That's why we did that ahead of time. But the first one, we'd have to grab a calculator again, because I don't remember I don't know 2.1 squared off the top of my head. But you're getting something like that. Dividing by a tenth is a lot like multiplying by 10. So we'll get 10 times whatever this works out to be. So 2.1 squared times 16. That's the thing we're subtracting. 40 times 2.1 is like 80.4, right? 40 times 2.1 was the first part. Right, plus 4 is what I meant to say. Sorry, 80 plus 0.1 times 40. So it's 84. Minus our 70.56. That's not 56, there you go. Subtract 16, and then multiply that by 10. So I'm getting negative 25.6 this time. Part C, you've got a step size like 0.05. So the interval is this, and your formula becomes 40 times 2.05 minus 16 times 2.05 squared, right? Subtract f of 2 and divide by your new step size. So if I go back to the calculator, we've got, well, yeah, I'll just do the weird part first. 2.05 squared times 16. 67.24. And then 40 times 2.05, it's like 82. You're subtracting this number, gives you 14.76. Subtract f of 2 from that and divide by 0.05. So we're getting negative 24.08, or sorry, 0.8 this time, negative 24.8. And then the last part, we've got a delta t of 0.01. That's like 1/100th of a step. So maybe I won't write it all down this time, but you're going to take 2.01 and square it and multiply that by, actually let's clear this first. Multiply this by 16. Hmm. 2.01 squared times 16. Yeah, that's right. Good. And then 40 times 2.01. Subtract this number. So 40 times 2.01. And subtract this number that we just found. We get this time. Again, subtract f of 2. And divide by 0.01, or multiply this by 100. Divide by 0.01. We'll move it 2 decimal places, you'll get 24.16. So this time, when we do it out, we get negative 24.16. And then the last part of the question was, like, estimate the instantaneous velocity at 2. If you look at our numbers, they went, 32 was pretty far away. That was kind of a huge gap in a sense, half a second. But yeah, negative 32 went down to negative 25.5-ish, close to negative 25. Now it's getting closer to negative 24. So if I had to guess, my instinct would be probably negative 24. I'm just staring at, yeah, that should be your instinct. That's about all you can say right now. If you know some calculus, of course, you can actually just take the derivative and get 40 minus 32t. And then when you plug in 2 to that derivative, you get 40 minus 64. But for now, our estimate is that the velocity at 2 is probably negative 24, because that's what it seems to be. It seems to be slowing down. There was a big jump from 32 to 25, but then it's jumping less and less as we take these finer and finer steps close to 2. So it seems like it's approaching negative 24, and that is actually correct. That's exactly what it is. Thank you for tuning in to our math challenges solutions today. Have a great day, ladies and gents.